Zoom zoom. See.
Okay, class, can you hear me, class? Can you hear me?
Yes.
Okay, sige. Can you turn on your camera so that we can start now? Turn on your cameras, please. Cameras on, please. Turn on your cameras. Okay, class, can you see the board?
Yes, sir.
Okay, sige, sige.
Yes, sir.
For today, we will have continuation of welded joints. No? For welded joints, just as a review, now for welded joints, eccentric. You know? When we say eccentric, meaning the load that does not pass through the center of gravity. So if it is concentric, meaning it passes through the center of gravity, meaning the load is evenly distributed. So if it is not eccentric, it is very easy. You just divide the force divided by the throat area, and that is the stress. And it is a direct, we call it the direct stress. However, when it is eccentric, we have two components of load. One is the direct load, because we transfer the loading from its position to the center of gravity, and that will also cause twisting. So meaning, when you have an eccentric loading, you have two kinds of stresses acting on the will joint. You have your direct stress and you have your twisting shear. The direct shear and the twisting shear. Okay, now let's look at this example for today. That's just as a review. No? So for today, let's look at this example. What we have here is again bracket, like a bracket, and the load is in the center. Load is symmetrical. We have 6 inches of web here, both sides, meaning this side and on the other side. And there's also this one, both sides, 1/4 inch fillet weld, this side and on the other side. And then you have a gap in between. Okay, and then your load P is on the center. So if I'm going to illustrate it, it is something like this, no? This side, and this side, also this side and this side. Let us say this is, what is yan? This is bangag dire. Ay, bangag. Oh, there is a hole in between, the middle, and then that is your two metals. You have a fillet weld here, and a fillet weld here, and also at the back, you also have a fillet weld and a fillet weld. That's why it's called inside. Any question regarding the interpretation of the drawing? Any question regarding the interpretation of the drawing? Okay, so you have your P, which is acting on the centroid because it is symmetrical. Symmetrical, left and right side. P is acting on the centroid of the group weld. Now we use an electrode of 6010. The yield force is 50,000 SI. You will find that in table 773 on page 350. All of these are 1/4 inch fillet. So basically, since the load passes through the center of gravity, then we can directly distribute the load and say that the load stress is equal to P over the throat area. Okay? So our throat area, 6 on this side, 6 on the other side, another 6 on this side, and 6 on the other side. But since this is a fillet, then sa may kuan, there should be a 0.707. So 2, 6 plus 6, 6 plus 6 times 2, because you have on the other side. Or if you want 6 plus 6 times 2, so whatever you want, then times the size of the weld times 0.707. So this is our area, throat area. So the stress is, since this is passing to the center of gravity, it is a direct shearing stress, which is P over the throat area. Okay, and so therefore it is what? 0.5 times the yield point over factor of safety, and we solve for P. Since all of these are given, factor of safety here is 2. So P, throat area, yield point is shear, and then your factor of safety. We get a value of P of 53,025 pounds. Any question? Huh? Solution is simple because it passes to the center of gravity, meaning the stress is evenly distributed, meaning any part of this, the joint, the stress will be equal. So, actually the question here is, how much, find that, will the joint carry? What is P? Given a factor of safety of 2. So our P here is 53,025. Okay? No question? Huh? Wala question? Then, let's proceed. For the next part, what we're going to do is we're going to modify the same bracket, but this time, we'll make the right portion a little bit larger. So you will notice, this is still 1/4 inch fillet, but this side is now 1/2 inch fillet. Okay, both sides. So what happens now? Okay, there is a shift of the center of gravity because this is now not symmetrical. So we expect that the center of gravity will move to the bigger throat area. Okay, let us say this is your center of gravity. So, ano ba itong center of gravity? O gawin ba itong function niya? Okay. Because I'm going to illustrate something here. So, now there is a shift in the center of gravity from the middle to the right side. So what happens now is that this becomes an eccentric loading. So if it is an eccentric loading, we expect that the load here passing through the center of gravity will now be rising on this one. And what is the other one? Moment. In what direction? In what direction? So you will notice that it is towards this direction or clockwise or counterclockwise? Clockwise, ano? Correct? You have this here. What will this peak of the joint to swing? This is clockwise, that is counterclockwise. What direction? This is your P, and this is your moment M. What is the direction of the moment? Clockwise. Clockwise, in this direction. Ano? Is that correct? This is your center of gravity and this is your P. So you replace this one with something like this and something like this. So these two will be a couple that is tending to rotate. In what direction? Ano mo siya? In what direction? So, is 1 and a half in half. This two is a couple that tends to rotate in that direction. Which is your P, and this is a couple which is represented by this. Any question? Or disagreement? Wala question? Okay, so let's proceed. So now we have a direct shearing stress acting on the center of gravity and a twisting shear stress M. But before we have to do that, we need to find the center of gravity. So, this time, since these two are not identical, we have to be careful with the 1/4 and the 1/2. So we'll first compute for the left front area, this front area. So it is 6 times 4.77 on this side, and on the other side, so you multiply it by 2. Now for the right front area, it is also 6 by 1/2 by 7 times 4.77, and then times 2 because you have the another 1 on the other side because it is both sides. So your total throat area is the total of these two. Okay? So once you have the throat areas, we can now find the center of gravity. Location of the center of gravity. Okay na? So far, certain? Understood? Okay. So, let's look at how we compute the center of gravity, this one. Our reference is on the left end, the rest. We take moments on the left end. So we say this throat area times its distance from this reference plus this throat area times its distance from the reference. So ang distance na to from the reference for this is how much? 3. For this one, 6 plus 3/4 plus 3/4 plus 3. Okay? So you understand this? 3 times this throat area plus 6 plus 3/4 plus 3/4 plus 3 up to the center here times throat area over the total area. Okay, so our location of the centroid based from the left edge is 11.33268. So that is our distance from the left edge of the centroid. Of course, we just subtract this one, no? Just subtract 6 plus 3/4 plus 3/4 plus 6 is minus this one. So that is 7.16374. So we can now compute for the direct shear. The direct shear is P over the throat area, total. then I simplified it by raising it up, taking the reciprocal of this, so that we can have a value which is not a fraction. Actually, you can try that, but the problem there is when you are adding this to another one later, okay? Now, the next is the polar moment of inertia. Okay. J. Kaya ito, kung natin J. A. L squared over 12 plus R squared. Okay? So, for the left one, the reference is the center of gravity. Area is given, A. Length is 6 squared over 12 times R, which is the distance from the center of this to the center of gravity. So how much is that? It is 11.3362 minus 3. Do you follow? So what? Oh. Now for the right well, again, area L squared over 12 plus the distance between this to that, which is actually 7.16374 minus 3, because the center of this is 3. So minus 3 squared. Then we are going to get this polar moment of inertia of the right well. Now the total polar moment of inertia is can now be added directly because our reference now is both on the center of gravity. This polar moment of inertia of the left well is about the center of gravity and also this one. So we add this to this, then we will have this. The next question here is the torsional stress. We now have computed the direct stress. How about the torsional stress? PR over J. But wait, which part are we going to analyze for the torsional stress? The farthest from the center of gravity, which is where? At A. Center of gravity, this is the farthest. Okay, so our P is how much? This distance times P. No, diba? This distance from the center of gravity to the position of the original P, which is how much? This is 11.3362 minus 6 minus 3.304. Ito ba? Okay? Balik. Sorry. Nabalik ako. Mali no? This one minus this one. Correct? Okay. So it is 11.33262 minus 6 minus 3 and 1/4. That's correct now? That is your P. And your R is the distance of the A from the center of gravity, which is 11 over the J, polar moment of inertia. So, you will notice that I also did not have the instruction. No? So, ini, you divide the one and put it to top. Belum baca ni. So, this one divided by this. Betul si decimal, no? Ha? 6. Hindi? 3, 3, 2, 6, 2. Okay. 3, 3, 2, 6, 2. Okay. So you compute this times this one over this one will become this. That's correct? Right? Let me calculate. .33 262 minus 6 minus 3.25. And 11.33 262 minus 6 minus 3.25. 2 divided by 2.0 02 651. How much did you get here? Okay. 11.33 262 minus 6 minus 3 under 4. So that is 2.08262. Then you multiply by 11.33 262. It will be 23. Divided by 214.02 651 0985 0983 sorry 0983 983 288 Nine, eight, three. So, 8, 8, 2, 8, 8, 9. That's correct? Now, the total shear is now the total of the direct shear and the twisting shear. What is the direction of the direct shear? What is the direction of the direct shear? At A. What direction? Last. What is the direction of the direct shear? Okay, since this is downward, then it is downward. How about the twisting shear? What's in here? In what direction? It is what? It is perpendicular to? Radius, which is what direction? Or radius is where? From the center of gravity to A. So what direction? Huh? So this is your direct shear. However, the perpendicular to this is also that one. And what direction? It is also downward. So therefore, this problem is not as complicated as the previous one because both have the same direction, which is downward. Even if upward means sa tayo drop. Minus ka pala to. Do you follow, class? Class, do you follow?
Yes, sir.
Okay. So, that is why our total shear is equal to the direct shear plus the twisting shear. You just add them together. Ayun, kaya siya, no? Like, panggamay. 9, 8, 3. 9, 8, 3, 2, 8, 9. So what we will have here is plus 0.15 71487. Two, 5, 5, 4, 7, 7, 6. Is that correct? Okay. So, this total shear, we're going to compute it as yield 14 shear with a factor of 50. So, 55477. 4776. So how much is P? So 0.5 times 0.5 times 50,000 divided by that one. Right? 0.5 times 50 divided by 2 divided by 0.2 97? 97 na lang. Is that correct? Around off? Okay. Now this is now the load fee that the welded joint can get it. Now if you compare the two, if we have a symmetrical distribution of the load, you will notice that we can carry a load of 53. However, if we try to reinforce, look up, we reinforce the right side. What happened? We can only carry 48. Is that anomalous? When we reinforce it, it becomes weaker. Is that correct? Huh? It seems to be anomalous, no? Because based from this one, it is 53. But if based from a thicker right side, so again, based from this one, we can carry a load of 53. We're both 1/4 and 1/4. Now, if we try to make this side stronger by making it 1/2 inch fillet, what happened is you can only carry 48. Okay. Now, the explanation here is that because there is a shifting of the weakest part, you are now placing the weakest part further from the center of gravity, which will give you a more twisting shear. So, in that case, dili ka pwedeng abigay atong pa ulingan atong pa kuan padako ulikon siya. Okay? Any question, class? Any question? Any question? Class? Dako?
Ano, sir? Wala rin question.
Okay, wala rin question. Did you compare the government and ground of wood? No, okay. Gamay naman na iyang significant figures. Okay. that we can slow part. May ito mo mga natin. Kung gano'n din si kayo, pero siya sa huya. Nagibutan ang load niya lagan dire. Initially, sila tanan parehas ang load, parehas ang stress. Pero i-shift mo ang iyong center of gravity, atong pinakalayo sa center of gravity will have a bigger twisting shear. So mas dako ang iyang carry. So it means also it will become weaker. So that is what happens here. So the advice here is that although A and B, comparing A and B, although the welds are larger on the right hand side at A, the right not at A, sorry. So comparing between A and B, although the welds are larger on the right than at A, than at case A, the carrying capacity of the joint has been reduced because of eccentricity. Again, that is the problem with eccentricity. The distribution of the load is not even. So, it is advantageous to maintain symmetry. Any question, class? Any question?
Answer.
None? Okay. So, that will be all for today. You take your screenshot. And then I'm going to again request volunteers for erasing the board. Ako muna yun. Wala makinig. Lahi. It's your turn. Anyway, the next meeting is the last. Next meeting is the last one. Sorry, yes, yes. Okay, na class, have you taken the screenshot?
Manager.
Okay, na report. Okay na? Ay, nyara. Are you done? Class? Okay. I'm going to ask you again to turn on your cameras. And... Turn on your cameras. Okay, turn on your cameras, please. Wala pa speak up. Ayan. Okay, Aaron. Pagbuhan na po, makita sa... Okay, class. Turn on your cameras.
Wala pa man good.
Okay, so reminder, no? Reminder for exam on Wednesday.
Ha?
Oh, Friday day, sorry. Wednesday,
Alam niyo ba nagamit itong water bottle ay kayang-kaya natin gawin itong churros? Pangalawang beses ko na ngayon paggawa nitong churros. Yung first attempt ko na paggawa nito ay hindi perfect kasi matigas siya. Pero itong pangalawa ay super perfect talaga, 101%. Paano ko ginawa to? Sa paggawa nito ay kailangan lang natin dito ng 1 can evaporated milk, yung 700 ml. Tapos naglagay rin ako dito
remember the coverage.
butter,
no? Na ako nang na-post.
Means,
Now, for the third exam, I'm going to post the coverage again. Just as a tip, sugod atong portion of circular siya.
pero kapag maglalagay
Ako na ako na i-post, maybe tonight, no? Portion of circular siya, then the design of circular siya. There are 3 methods of designing circular siya. You have the asmicol, the maximum shear stress theory, and the Mississippi theory. Pag-design na siya sa katong paano siya.
Sa paggawa nitong churros ay kailangan talaga meron
And then,
kasama para meron kayong kapalitan sa paghalo nito dahil
there's
sobrang
also the
sakit
key.
talaga sa braso.
So, key.
Pero once naman na nagawa nyo ng perfecto ay super worth it naman. At ito na nga pala yung gagamitin ko na
And then there's also the flange coupling.
iwaan ko lang siya sa taas. Pinapit ko rin pala yung sa gitna niyan yung masyadong
And last part
kasi
is
parang
the
naputol lang.
bending loops in two planes.
Tapos kasi simulan na kaagad ni ate lagyan ng dough itong water bottle.
Now for the bending loops in two planes,
Itong water bottle para hindi kami mahirapan magpasok itong dough sa
design na ni siya,
at habang
meaning you have to compute now for the moment and the torque.
Sakto naman, pagkayot na naman.
Katong bending loops in two planes, moment naman ito itong i-compute ato.
Habang nilulutuan
Oh.
namin ito, napapasok.
Kaya pag-design na to, whether we are going to use asmicol, maximum shear stress theory, or Mississippi, kinahanglan mo tag-torque. Kinahanglan mo tag-moment. So, application sa bending loops in two planes, kaning design of the shaft, which needs the moment and the torque.
Binilang ko nga pala itong churros na nagawa namin ay 40.
I'm going to post this tonight.
O diba, sa 2 and 1/2 lang na flour ay sobrang dami na namin.
The schedule is November 28, no?
Ay nagtunaw lang ako ng chocolate chips. Pero kapag wala naman kayong chocolate chips, ay pwede kayong gumamit ng Milo. Mas masarap rin pala to kapag isawsaw nyo sa condense. Mas bet ko yung condense kisa dito sa chocolate. Kaya naman kung ibang bibenta nyo to, ay pwede nyo itong ibenta ng 5 pesos isang piraso. Tapos yung gamitin nyo na lang na dipping sauce ay yung Milo. Mas mura kasi yung Milo kaya sa condense or di kaya sa chocolate chips. Pwede nyo rin gawin sa bahay nyo to at pang merienda ng mga kids nyo. For sure magugustuhan nila to. Hindi na nga
Bye.
sprinkle lang sila nun dito sa taas kasi ayaw namin.
Alam ba, that will be for the last na pa my post. When they join, so ka na.
Next year na ng counter, 40 exam.
Kung sa to?
40 exam sir ba? Next year na or karong December.
December. Okay, class, any questions? Okay, so if no questions, then thank you for a successful lecture for this afternoon. And keep safe and bye. Bye.
Thank you sir. Bye sir.
Hello, sir. Sige,
Thank you sir. Thank you sir.
Sige,
Yes,
thank
sir.
you for Bye.
Uy, aalong man.